Group 7, the halogens. Halogens are the elements that belong to group 7 in the periodic table. And in this presentation, we are going to look at some physical properties of these halogens. For example, their color. The elements in group 7 of the periodic table are fluorine, chlorine, bromine, and iodine. You can see that chlorine has a pale yellow to green color. As for bromine, it has an orange color. Iodine has a dark violet color. This table here summarizes the properties of halogens: the color, the boiling point, and the state at room temperature. Notice that the boiling point increases as we go down the group from fluorine to iodine. Fluorine and chlorine are both gases at 20 degrees Celsius. Bromine is liquid and iodine is crystalline solid at 20 degrees Celsius. Let's answer some questions. Match each halogen to its description. Chlorine. What's the color of chlorine? Is it gray to black crystals, orange to brown liquid, or yellow to green gas? Correct. Chlorine is yellow to green gas. What about bromine? Excellent. Bromine is an orange-brown liquid as you saw in the picture. What about iodine? Correct. Iodine are gray to black crystals. They have a very dark color. Now decide whether the following statements are true or false as we go down group number 7, which are the halogens. The halogens get darker in color. Is that true or false? That is true, and you can get the evidence from the above question. Where from chlorine to iodine we are moving down the group, and as we are moving down the group, the color is getting darker from pale yellow to green, then orange to brown, and finally gray to black crystals. So, do the halogens get lighter in color as we go down the group? That is false. Halogens get darker in color. As for the boiling points of halogens, do they increase or decrease as we go down the group? Excellent. The boiling points of halogens increase as we go down the group, which means that the element that is found at the bottom of the group has a higher boiling point than the elements that are above. This is a trend in the group number 7. Actually, halogens exist as diatomic molecules. What does that mean? This means that halogens, like chlorine for example, cannot exist as an atom alone. It needs to exist as a diatomic molecule, which means chlorine bonded to another atom of chlorine. Di means 2. Chlorine atoms have 7 electrons in their outer shell. This means that they need 1 electron to fill the shell and have 8 electrons in the outermost shell. So 2 chlorine atoms share a pair of electrons in a covalent bond. Both chlorine atoms now achieve a full outer shell in the diatomic Cl2 molecule with 8 electrons in their outermost shells. This is how all halogens exist. They exist as diatomic molecules.